All right, we're about to open the case file on what might just be the biggest mystery of all time. We're not just looking at science here, we're launching a full blown cosmic investigation.
You know the question. I mean, it's a question that has echoed through pretty much all of human history, through our stories and our science. It's so simple, but so profound, and it's what makes us all look up at the stars and just wonder. So for this explainer, we're going to put on our detective hats. We're going to trace the clues, follow the evidence, and see what the science of astrobiology can actually tell us. You could say this is the ultimate cold case.
Okay, so you know every good investigation has to start by marking off the search area. But in our case, the crime scene isn't just a room, it's the entire universe. So where on Earth or off it do you even begin?
Well, the first big clue is water. As far as we know, life needs liquid water. So astronomers start by hunting for what they call the Goldilocks zone around stars, an area that's not too hot, not too cold, but just right for water to exist. And believe it or not, we can zoom out even further than that. Turns out it's not just about a planet's distance from its star. There's a habitable zone for the whole galaxy. Get too close to the center, you're getting blasted by deadly radiation. Get too far out, and there's not enough of the heavy elements you need to build planets or, well, us. It's all about being in that galactic sweet spot. And here's where it gets really interesting. This is Exhibit A in our case. We're about 27,000 light years from the galactic center, which puts us smack dab in the middle of this habitable zone. Our own existence is maybe the best piece of evidence that this is a great place to start looking.
Okay, so we've got our search area locked down. Now, for the next step in any investigation, what are we actually looking for? What are the forensic clues, the fingerprints of life itself?
Well, using radio telescopes, scientists have figured out that the universe is basically one giant, fully stocked kitchen. It is just filled with the complex organic compounds you need for life. We're not talking about just simple stuff. We found carbon-based molecules floating around out there in deep space. The pantry is full. And get this, we don't even have to look that far away for the evidence. Sometimes it comes right to our doorstep. Certain types of meteorites are like these little packages delivered straight from the early days of our solar system. And when we crack them open, guess what we find? They're loaded with the same kinds of organic compounds. It really suggests the building blocks of life are everywhere.
So the huge question then becomes, can these simple ingredients actually assemble themselves into the building blocks of life? Well, way back in 1952, the Urey-Miller experiment proved that yep, they can. They basically recreated the conditions of early Earth in a lab, zapped it with a spark to act like lightning, and voila! They created amino acids, the very things that make up proteins and life itself.
Okay, let's recap the case file. We've got a location, we've got the ingredients. That's a ton of circumstantial evidence. But that's not enough. For this investigation, we need a smoking gun. We need to catch someone in the act. So what if we just listened in? And that's exactly the job of SETI, the search for extraterrestrial intelligence. For decades now, scientists have been using these absolutely massive radio telescopes as cosmic wiretaps, just eavesdropping on the universe, listening for any signal that doesn't sound like natural static. A message, a beacon, anything that says, hey, we're here.
So after all that listening, all that searching, what have we found? What has our cosmic wiretap picked up? After more than 40 major searches, pointing our best tech at the most promising stars, we've heard absolutely nothing, just a profound, deafening silence.
So, what gives? Why is it so quiet? Well, there are two really simple but also really stark possibilities. The first one is maybe the most unsettling. There's just nobody home. Nobody else is out there to find. The second is a problem of sheer scale. The galaxy is just so mind-bogglingly huge that even at the speed of light, a simple back-and-forth hello could take tens of thousands of years.
This whole silence thing, it's a real head-scratcher. So, like any good detective would do when the trail goes cold, let's step back and try to build a profile. Let's try to calculate the odds. How many civilizations should we be hearing from?
And the main tool for this job is something called the Drake equation. Now, it's not some magic formula that just spits out a perfect number. A better way to think about it is as a framework, a way to organize all of our ignorance into one neat little package. See, it works by breaking one giant, impossible question, how many aliens are there, into smaller, slightly less impossible questions. We can make pretty good guesses about stars and planets. We can even take a stab at how often life might pop up. But the real kicker, the variable that changes everything, is the last one. How long does a technological civilization stick around? That L is the great unknown.
And this is where our detective story gets really, really weird. Because when you run the numbers, even with the most pessimistic, conservative estimates, the Drake equation suggests the galaxy should be buzzing with civilizations. But what our observations show us is nothing. This is truly the ultimate unsolved case.
I mean, that's the question that just haunts this entire field. If the ingredients are everywhere and the universe has had billions and billions of years to cook, then where is everybody?
In this massive cosmic contradiction, it actually has a name: the Fermi paradox. It's that huge gap between the high probability that says alien life should be common and the complete and utter lack of evidence we've found so far. It is the single biggest mystery in our cosmic case file.
So how do we solve it? Well, the potential answers are fascinating and, honestly, a little frightening. Maybe we're just the first ones to show up to the cosmic party. Or maybe space is just too big and the distances are an impossible barrier to cross. A darker idea is that maybe intelligent life is just a brief flash that always inevitably destroys itself. Or maybe everyone's just listening and nobody wants to be the first one to shout into the dark.
Right now, there are just no easy answers. The clues are all there, but they point in completely different directions. The evidence for life's potential is everywhere you look, but the hard evidence of its existence is nowhere to be found. The case remains wide open.
And that leaves us with the final, haunting question of our whole investigation. Are we the first ones to wake up in an empty house just before the party's about to start? Or is that silence telling us something much more profound? That in this great silent dark, we are utterly and completely alone. The search for that answer continues.